Solve for x and give exact solutions. Now for this problem, I have a degree 4 polynomial. And at this point, I don't really know how to factor a degree 4 polynomial. However, I do notice that 4, I can rewrite it as 2 to the second power. So I'm going to make use of that fact and rewrite this polynomial as x squared raised to the second power. Now I'm going to subtract 3x squared and I'm going to subtract 28. By doing this, now I have 2 copies of x squared. I'm going to make the following substitution. I'm going to let u equal x to the second power. So everywhere I see an x squared, I'm going to exchange it for a u. So now I have the following polynomial. I'm going to have p of x equal to u to the second power minus 3u minus 28. And this polynomial looks a lot like a quadratic. Usually we have x squared minus bx plus c, but now we're using the variable u. And since my leading coefficient is 1, I can apply the diamond method. I need to get the two numbers that are going to multiply to negative 28. But if I decide to add them, they're going to give me negative 3. And the two numbers that multiply to negative 28 but add to negative 3 are going to be negative 7 and positive 4. So I get negative 7 and positive 4. Because negative 7 times 4 is negative 28, but if I add negative 7 with 4, I'm going to get negative 3. So I can rewrite this polynomial as p of x equal to, we're using u, so I can rewrite p of x as u minus 7 multiplied with u plus 4. Now because I'm trying to solve for x, I'm going to let p of x go to 0. And as I do this, I'm going to exchange my u back to x squared because again we're trying to solve for x, we're not trying to solve for u. So here I get x squared minus 7 multiplied with x squared plus 4. And using the zero product property, I now have x squared minus 7 equal to 0 and x squared plus 4 equal to 0. I'm going to solve the equation on the left, so I'm going to add 7 to both sides. And I get that x squared is going to equal positive 7, since 0 plus 7 is 7. Now I'm going to take the square root of both sides so that I can eliminate the exponent of 2. So on the left, the square and the square root cancel out, and on the right hand side, I'm left with plus or minus root 7, since I cannot take the square root of 7. 7 is not a perfect square. Now here we're going to subtract 4. And on the left hand side, we're left with x squared. On the right hand side, 0 minus 4 is negative 4. I'm going to take the square root of both sides. And then on the left hand side, the square and the square root are going to cancel out. So I'm left with x equal to, here I have a negative 4, so I'm going to get a complex solution, or an imaginary solution I should say. We're going to get negative 2i, plus or minus. So let me go back and write that, plus or minus 2i. And those would be my 4 solutions. My 4 solutions are root 7, negative root 7, 2i, and negative 2i.